Hello, my dear friends. Welcome back. Today, I am going to take one more problem and I am going to find the value using graphical method. So, this I am taking again from solving an LPP by graphical method from operations research. So, here we have the problem. Solve the following LPP by graphical method. We have here min z is equal to 3x1 plus 2x2 subject to constraints 5x1 plus x2 is greater than or equal to 10, x1 plus x2 is greater than or equal to 6, then we have x1 plus 4x2 is greater than or equal to 12. Fine. Then we have x1 x2 is greater than or equal to 0. So this is the problem that we have, and we have to find out this min z value here. Now, as you know, the first step in solving an LPP by graphical method is to convert the inequality into equality. And here we are going to replace this greater than or equal to sign by is equal to, that is 5x1 plus x2 is equal to 10, x1 plus x2 is equal to 6, x1 plus 4x2 is equal to 12, and x1 x2 is greater than or equal to 0, and hence we are going to get what? We are going to get this these equations here, which is min z is equal to 3x1 plus 2x2 subject to constants, and we have all these equations here. Now the next step here is what we have to do. We have to find out the values of these x1 and x2 in all these equations, right? We have first equation, we are going to find out the values of x1 and x2. Then we have second equation, we are going to find out again the values of both these x1 and x2. Then here again we have to find out the values of x1 and x2. Now how are we going to find the values here? We are going to substitute, or we are going to assume the value of either of these two, that is x1 or x2. Fine. So if we place or if we substitute here x1 is equal to 0, so whole this part will become 0 and x2 will be is equal to 10. Now if we keep this or substitute this x2 is equal to 0, then 5x1 will be is equal to 10 and x1 will be 10 by 5, that will be is equal to 2. Now let us go for this and find out the values of x1 and x2 in all these three equations. Now here we have this. Now see here, as I said you, we have the first equation here, right? In that first equation we have x1 and x2 values here, right? x1 and x2, we have to find out these. Now if we see first one, as I said you, we are going to place this x1 is equal to 0 here, right? If we place 0 in this one, this whole will become 0, x2 is equal to 10, that is what we have here, x2 is equal to 10. Now if we put this x2 is equal to 0, then 5x1 is equal to 10 and x1 is equal to 10 by 5, that is equal to 2 here, right? So we are going to get x1 is equal to 2 and x2 is equal to 10. Similarly in equation second, if we are putting x1 0, right, so x2 will be 6. Now if we put x2 is equal to 0, then x1 will be is equal to 6, that is why we have here x1 and x2, and we have x1 is equal to 6 and x2 is equal to 6. Fine. In this equation, if we substitute the value of x1 is equal to 0, so 4x2 is equal to how much? This is 4x2 is equal to how much? It is equal to 12, right? 4x2 is equal to 12, right? Then x2 will be how much? x2 will be is equal to 12 divided by 4, right? So 12 divided by 4 is how much? 12 divided by 4 will be is equal to 3, that is what we have here, right? This is what we have here, x2 is equal to 3. Now if we substitute this x2 is equal to 0, so all this value will become 0. So x1 will be how much? x1 will be 12, that is what we got here, x1 is equal to 12 and x2 is equal to 3, right? So after this, what we are going to do, we are going to plot all these x1 and x2 values on the graph. Fine. So we are going to plot all these on graph. Let's go for that. Now say for example here in this graph, let this one be x1, this x-axis is this be x1 and this be x2. Now the first equation we have, and we have got the values there which are what? x1 is equal to 2, let this be x1 is equal to 2 and x2 is equal to 10. So this is here x2 and this is x1. So next what we are going to do, we are going to connect these two points, right? So after that what we are going to do, we are going to write down the equation on this line. It is 5x1 plus x2 is greater than or equal to 10. Fine. So in the second equation we have x1 and x2 values both are equal to 6, right? So this is the x2 value and this is the x1 value, so both are 6 and we are going to connect them and then we are going to write down the equation on this line, right? Then we have last one where x1 is equal to 12 and we have x2 is equal to 3. Also we are going to connect these two points and then we are going to write down the equation on this line. Now if we see here, the case is of what, minimization, and if we look at these equations, if we see all are greater than sign, all are having greater than sign. Now if we see which would be our feasible region, the feasible region would be somewhere here above. I will draw that line here, it will be somewhere like this if I am not wrong, right? So this will go like this, will go like this one. So this would be our, above this would be our, this would be our feasible region, this would be our feasible region, right? Am I right? Without without like coloring it, we can know that, we can understand. Like if we go on coloring this part, if we go on then coloring this part, and then if we go on coloring this part is greater than, and if we go on coloring this part, so it is quite simple here that this is the part which is going to be what, the area of what, this is going to be the area of feasible region. This is what I am talking about here, this one, from here then this one. Now we have to find out the corner point is here. The corner point is here would be starting from this point, then we have this point here, then we have this point, then we have this point. That means we have 4 corner points here and we are going to find out the value at these 4 corner points. What value we are going to find out? We are going to find out min z value here, right, for x1 and x2. Fine. So let us go for that. Now we have got these 4 values here, 4 corner points here. Let this be A, this is B, this is C and this is D, and this is the area, this is the region which is called as feasible region. Fine. So let us calculate what, let us calculate these corner points here. Now if we talk of this point A, at point A we have x1 0 here and x2 is 10 here. So that is what we are going to write down, x1 is equal to 0 and x2 is equal to 10. We are going to substitute these values of x1 and x2 in our objective function to find out the minimum min z value, right? So let us go. Fine. So this is our point A where we have x1 is equal to 0 and x2 is equal to 10. So what we are going to do, we are going to substitute this in min z is equal to, we have min z is equal to 3x1 plus 2x2, right? Now this value is how much, this x1 value is 0, so whole part will become 0. This will be how much then, 2 into 10, right? So 2 into 10 is how much, 2 into 10 is 20. So that is what we got here, this 20 value. So how is it, we have substituted the value of x2 is equal to 10 in this equation, so we have got how much, 20. Now we are going to the point B. Now if we look at this point B here, 2 equations are intersecting here. As I said in my previous videos, what we can do, if we are plotting this graph on any graph sheet, we can draw a perpendicular line from here to x1 axis and one more perpendicular to the x2, right? So then we are going to find out the values there. Now here we don't have the graph values, so what we can do, we are going to take these 2 equations, equation this and this equation, because these are the 2 equations which are intersecting here at this point, and then we are going to find out the values of x1 and x2, right? Now my dear friends, if you want to know how to find out the values of x1 and x2 at the point of this intersection, please do watch my previous videos. So here I am going to directly tell you what are the values of this x1 and x2, right, so that we can save our time and directly find out the value of min z. Now at this point B, which I said you, there after calculating we are getting x1 is equal to 1 and x2 is equal to 5. So when we substitute x1 here, it will become 3x1 is equal to 3 plus 5 into 2 is how much? 10. That is 3 plus 10 is how much? 3 plus 10 is 13. That is what we have got here. Then we have point C. If we look at this point C, we are going to find the values of x1 and x2 by two different ways. One is to draw a perpendicular line to both x1 and x2 and find out the values of x1 and x2, or we are going to find the two equations which are intersecting here. So if I see here, it is x1 plus x2 is equal to 6, then x1 plus 4x2 is equal to 12. These are the two equations that we are going to take and find out the values of x1 and x2 at this intersection point, that is C. Now directly if I tell you, at point C we have x1 is equal to 4 and x2 is equal to 2. Now if I replace here, x1 is equal to 4, that is 4 into 3 is 12 plus 2 into 2 is how much? 4. So 12 plus 4 is how much? 16 we are going to get here, right? Now if we go to the point D, here if we see here, x1 is directly 12 and x2 is 0. So we are going to take x1 is equal to how much? X1 is equal to 12. This is here. So we are going to write down 3 into 12 plus x2 is 0. So 2 into x2 is how much? 0. So 2 into 0 is 0. So 3 into 12 is how much? 36. So we are going to get how much? We are going to get 36 here, right? Now if we see out of all these values, because the objective function is about minimization case, right? When the objective function is a minimization case, so what we have to do? We have to find out the minimum. We have to find out the minimum value of all these here. Now see here, we have 20, we have 30, we have 60 and 16, we have 36. Out of all these we have this 13, which is the minimum value here. So we are going to tell min z is equal to how much? Min z is equal to 13, right? For which x1 is equal to how much? X1 is equal to 1 and x2 is equal to how much? X2 is equal to 5. All right, so this is how we are going to find out the value of min z. That is how we are going to solve an LPP here by using a graphical method.